All right, let's dive into a really foundational concept in industrial automation. We're going to break down how some simple, step-by-step logic can create some pretty complex and cool real-world actions.
It's a great question, right? You see an automated arm on a factory floor and it looks incredibly complicated. But at its core, it all boils down to a set of simple programmed instructions that are controlling physical parts, telling them exactly when and how to move.
So to really get our heads around this, we're going to look at a super common industrial application, a pneumatic gripper. Its whole job is to do what's called a pick-and-place operation, basically moving an object from one spot to another, over and over and over again, with perfect precision.
Okay, so its mission is this very clear four-step dance. First, the arm extends out. We're going to call that A+. Then the gripper closes to grab an object, that's B+. Next, the arm retracts, bringing the object back, A-. And finally, the gripper opens up to release it, B-. The whole goal here is to create a perfect, repeatable loop.
Now, for this whole process to work, you need three key components working together in perfect harmony. And a really good way to think about them is as the system's brain, its muscles, and the special language they use to talk to each other.
First up, you've got the brain, the PLC, or Programmable Logic Controller. Think of this as a tough little industrial computer that makes all the decisions. It reads our program, and based on the logic we've given it, it tells the muscles what to do.
Next are the muscles of the operation, the pneumatic cylinders. These are the parts that do all the actual physical work. They use compressed air to extend and retract, moving the arm forward and back and opening and closing that gripper. And finally, the language that connects the brain and muscles is called ladder logic. It's this wonderfully simple, visual way to write instructions for the PLC. It's actually designed to look like an electrical wiring diagram, which makes it super intuitive for the folks who work with these systems every single day. And what's so powerful about ladder logic is right here on the screen. It's all about simple conditions and actions. The condition is, if switch X0 is on and switch X1 is on, then the action is turn on the lamp Y70. We're going to use this exact same if-then principle, just with timers and sequences to control our entire gripper operation. Okay, so let's move on and see how this all builds into that four-step sequence for our gripper. We're going to break down the ladder logic for each and every phase of the A+, B+, A-, B- cycle. The entire sequence kicks off the second a trigger, like a push button, starts a master running timer. This timer immediately turns on the very first output, which we've labeled Q0, for exactly 2 seconds. So what's happening in the real world? Well, that Q0 output is wired to a solenoid valve. When Q0 turns on, that valve opens, it sends compressed air into cylinder A, and that causes it to extend. This is our A+ step. The gripper is reaching forward. Now this is where things get really clever. At the exact same moment that main timer starts, it also kicks off a second timer. This one has a 1-second delay built in before the next action happens.
That 1-second delay is absolutely critical. It's programmed in there to make sure the arm has enough time to fully extend before the gripper even tries to close. You got to get it just right. After that second is up, output Q2 turns on, firing up the valve for cylinder B, and that makes the gripper close down on the object. That's our B+ step.
All right, for the next step, the trigger isn't based on time anymore. Instead, it's triggered by the completion of the step before it, creating this really cool logical chain of events. And this is just a beautiful illustration of cause and effect in programming. Remember how output Q0, the one that moved the arm forward, was only on for 2 seconds? Well, the moment it turns off, the PLC logic sees that and uses it as a trigger to turn on a different output, Q1. This energizes the other solenoid on cylinder A, causing it to retract. A- is done.
Finally, the sequence wraps up with the last action, releasing the object at its new destination.
And just like before, this is another cause and effect step. The logic is just waiting for output Q2, that's the grip command, to turn off. The moment it does, bam, that triggers output Q3, which retracts cylinder B. The gripper opens, the object is released, and the B- step completes the entire cycle.
So we get the logic. But how does an engineer actually get this program from their head into the PLC's brain? Well, it involves a few key steps inside a software environment, something like Siemens TIA portal. The whole process is really methodical. First, you create a new project file. Then, you tell the software exactly which PLC you're working with, because different models have different capabilities. Then comes the fun part. You actually write the ladder program, dragging and dropping contacts and coils to build out the logic for each step. Finally, you connect your computer to the PLC, you download the program, and you switch it to run mode to bring your logic to life.
Okay, let's zoom out for a second. We've gone really deep on a simple A-B sequence for just one gripper. So why does understanding this seemingly small process actually matter in the real world?
Because this fundamental principle, using a programmed brain like a PLC to control physical muscles like pneumatic cylinders, is the absolute foundation for nearly all modern industrial automation. I mean, from car manufacturing plants to the systems that package the food you buy, this simple, sequential logic is at work, scaling up to create incredibly complex and efficient systems.
By understanding these fundamental building blocks, the brain, the muscles, and the language, you can start to see the hidden logic behind the complex, automated world that is all around us every single day.
Like, share, and subscribe for appreciation and such more content.